Welcome to GeoK. My name is Asha, I'm a geologist and I live in Oslo. On this channel I will present new articles from the milieu of geology, old articles which had significant value for how we view the Earth, or maybe some geological trips. But grab a cup of tea or a cup of coffee and let's talk about geology. So today we're talking about old news, where I'm presenting an article written by William Hopkins, a geologist and a mathematician from the 18th century. The article is written in 1838 and it's called On the Phenomena of Precession and Nutation Assuming Fluidity of the Interior of the Earth. I will link it here, or yeah. And why I chose this article and why it's so groundbreaking is because he challenged the view of how they viewed the Earth, the interior of the Earth at the point, which was that it was solid all the way through. So he starts off his article discussing the two different ways of losing heat. You have heat can either be lost through convection or through conduction. So when you have convection, it's a gas or a liquid, and the hotter material rises and the colder material sinks. So it's also what makes the convection, what we think makes the convection cells today. We think there's a convection cell like in the Earth, interior of the Earth, it's believed today. Conduction is when there's heat transfer from one solid object to another solid object, and it travels from hotter area to a colder area. The hot material transfer goes towards the colder area. So that's the two different methods of losing heat. So then he goes through the concept that the mechanism that drives solidification of the Earth. And he states that since the heat increases with distance from the surface while the mass is cooling by circulation, the tendency to solidification, so far as it depends on this cause, will be greatest at the surface and least at the center. Then he states that, but on the other hand, the pressure is least at the surface and greatest at the center, and consequently the tendency to solidify, as depending on this cause, will be greatest at the center and least at the surface. So this is quite interesting, it's in the rest of the article he's kind of like going through different scenarios, and he comes to two main conclusions, or he comes to three different scenarios that can be possible. So the observation he does about convection and conduction and the transfer of heat, or the losing of heat, and the observation he does about the solidification of the Earth and which forces are governing that, he goes through and some arguments back and forth whether or not which is possible, but comes to the conclusion that he can make no conclusion. But also state that there is three different scenarios that's possible. And the first one is that it may consist of a solid exterior shell and an internal mass in a state of fusion in which fluidity is greatest at the center. That's the first one. The second one is that it may consist of an exterior shell and a central solid nucleus in which the matter is a state of fusion between them. And this is what we think today. So they were quite close already in 1838. And then the last one, which was the governing idea at the time, which was that the Earth may be solid from the surface to the center. Okay, drum roll. Okay, yeah, so now William Hopkins does something that we do quite, well, I wouldn't say often, but sometimes in geology, and that is he makes an assumption. And he assumes that the first scenario that he pointed out, that the Earth has a hard shell and a viscous interior. If it was so, he states that would the Earth orbits around the Sun and the Moon's orbit around the Earth still be in equilibrium? Would the forces governing still be in equilibrium? And he does a lot of calculations. I will show them here. You can see they're very beautiful. I won't go through them. If you want to go through them yourself, you can look at the article. But the conclusion is that it's totally possible for the Earth to have a fluid interior, and therefore it's yeah, so that's the main point. Okay. So thank you for watching, and I hope this was informative and fun and interesting, and I hope to see you next time. By any means, have a rocky day.